Right, and this is the final lesson of Chapter 6 if you're one of my students, you're in your study guide. It's titled Homework Practice. We're just going to investigate an optimization problem from your homework. It says, this is question number 4 for your homework assignment. If you go over this problem with Mr. Martins in class or via this YouTube video, you do not have to do it as part of your homework assignment. So you may want to pause this video at some point in time and try and finish it on your own, or you may want to follow along with me. But it's an optimization problem where we're trying to find a maximum or minimum combination for a particular solution. Here's the problem, and we've got some nasty critters happening here. Number 4 says this: Ed found spiders and crickets in his storage room. Unfortunate. Here's some constraints. There were 20 or fewer spiders. That's a particular constraint, that there's 20 or fewer spiders. So I'm going to highlight that. And there's 20 or more crickets. So you can't have any more than 20 spiders, and you can't have any less than 20 crickets. Another constraint would be the next sentence. There's 45 or fewer crickets and spiders in total. So in total, he's got no more than 45 insects in his storage room. And a statement of fact: spiders have 8 legs and crickets have 6 legs. That's not a constraint, just a fact. Part A says, what combination of spiders and crickets would have the greatest number of legs? And part B says, what combination would have the least number of legs? Well, something I want to point out is I actually know the answers without even setting up the solution region or setting up the inequalities, etc. But what we want to investigate is how to create the solution region and how to use that solution region to come up with the maximum or minimum. But if I look at this carefully, the combination that would have the greatest number of legs would be as many spiders as possible, so 20 or fewer spiders. So let me say that would be 20 spiders, because I want as many spiders as possible, and also as many crickets as possible. But if there's 45 or fewer, then I can only have 25 crickets. That's going to be the most possible legs, as many spiders as possible and as many crickets as possible. Part B says, what combination would have the least number of legs? Well, you're allowed to have 0 spiders. It says 20 or fewer. 0 is fewer, but you cannot have any less than 20 crickets. So in total here, the least number of legs is going to be 20 crickets. So if we had 0 spiders and 20 crickets. So I already know the answer, if I'm very careful about reading this problem, about what the most number of legs and least number of legs are. But we want to investigate this using a solution region and setting up inequalities just as practice as well. So let's look at the constraints here. There's 3 of them. I've highlighted them. You may want to pause this video at some point in time. If you have the study guide, you may want to pause it and start labeling some of these axes. I've gone up by 5s because the highest number is 45, and that makes the best use of this particular graph. And I've labeled the horizontal axis spiders and vertical crickets. And you may want to pause this at this moment and try this entire problem. Okay, you may have tried it on your own, or you may have not. The first sentence says there's 20 or fewer spiders. So if I'm to set that up, that says that spiders are less than or equal to 20. So spiders are equal to 20 here. And since there's no reference to crickets, this is going to be a vertical line through the spiders at 20. And if it's less than, fewer than 20 spiders, that would be that particular region there. Now if it says 20 or more crickets, that would be that crickets are greater than or equal to 20. And that would be this particular boundary line here. And it says that there's 20 or more, so I would shade above the 20 line. The last inequality says 45 or fewer crickets and spiders in total. So if I add the 2 types of insects, spiders plus crickets, I have less than or equal to 45. That boundary line will be a slanted line because it has 2 variables. And the easiest way to do that is find the 2 intercepts by substituting in 0 for each variable separately. So your boundary would be where s plus c is equal to 45. So if I substituted s, or spiders being 0, into that function, you would get that crickets are 45. So that would be this c-intercept right here. And if I substituted c is equal to 0, I would get s is equal to 45. And that would be this intercept right here. So that boundary line would be a slanted line between the 45s on each axis, looking like this. Okay, and since it says 45 or fewer, we would shade below that particular boundary line. So as you can see, your solution region based on the constraints is what I'm outlining in black here. And we can look at where the corners are. Here are your corners. So your corners would be 0 spiders and 20 crickets, 20 spiders and 20 crickets, 20 spiders and 25 crickets, and 0 spiders and 45 crickets. Okay, so that's the corners that we're going to investigate. And what we're trying to optimize, so maximum or minimum, is the number of legs. So the objective is the greatest or least number of legs. So if I'd like to represent that as an objective function, it would be that legs is equal to 8 per spider plus 6 per cricket. Okay, now to investigate these corners, I can already tell you that this would be the least number of legs, because 0 spiders and 20 crickets would have the least number of legs. So I don't even have to investigate any other points for the minimum. So the minimum is definitely going to be 0 spiders and 20 crickets. And that would be, the number of legs would be 8 times 0 spiders plus 6 times 20 crickets. That would be 120 legs. That's your minimum. So that's our answer to, actually, part B. Part A says, what's the most number of legs? Well, it's definitely going to be one of these 2 points where there's 45 insects, and you could use your common sense. 20 spiders and 25 crickets will have more legs, because spiders have more legs than crickets, than just 45 crickets. But we know it's definitely not this point. It's not this point. You could test both if you'd like to. So we could ask ourselves which one is going to be a maximum. Is it going to be 0 spiders and 45 crickets? Well, the number of legs there would be 8 times 0 plus 6 times 45. And that would be a total of 270 legs. Or another possibility would be, is the max going to be 20 spiders and 25 crickets? The number of legs there would be 8 times 20 plus 6 times 25. And that would be 160 plus 150, and that's a total of 310 legs. So that would be our actual maximum. And that's our answer to part A. So this is not our maximum.